All right, so for this review question, right, the net ionic reaction, when we make an aqueous solution of iron 3 hydroxide or iron 3 nitrate is mixed with potassium hydroxide. So the molecular equation first. So iron 3 nitrate would be FeNO3, 3 of those, because nitrate is +3 and nitrate is -1, right? Right here is nitrate, it's -1 each. That's aqueous, and I'm going to react that with potassium hydroxide, which is also aqueous. This is our molecular equation, so we're going to write everything as a molecule. And what are possible products of that reaction? So what can we mix when we mix, what can we make when we mix these two things together? Yeah, Josie. Yeah, iron hydroxide, right? We want to exchange. Iron's the cation, hydroxide's the anion. So those are the only two things I can bring back together. So if we take a look, right, iron and hydroxide is also -1. So that means I need to have 3 hydroxides on iron 3 hydroxide. And the other possible product is going to be potassium nitrate. So the next thing we want to do is figure out, well, two things. We have to balance our chemical equation. Right now, we're not balanced. So I have 3 nitrates on the left. I need to have 3 nitrates on the right. So if I add this 3 in front of the potassium nitrate, that balances out nitrate. I need to have 3 hydroxides. I need to have 3 potassium. So I'm going to add the 3 here as well to that potassium hydroxide to balance my reaction. Now we're balanced. And then the next thing we want to do is we want to figure out, right, what's precipitating from this reaction. So nitrate is always soluble, right? So there's no nitrate that's going to precipitate. So iron nitrate is soluble. Potassium nitrate is also soluble. So that's aqueous. Don't see iron listed anywhere, but we do see hydroxide. So hydroxide is insoluble unless it's with a group 1 metal or ammonium or a few group 2 metals like calcium, barium, and strontium, right? Iron is not a group 1 metal. Iron is also not a group 2 metal. So what that means is we're going to precipitate iron 3 hydroxide solid. So now, to go from our molecular equation to our net ionic equation, we want to remove, we're going to ionize anything that should ionize and remove our spectator ions. So our ionic equation, if I can have enough room, our full ionic equation would look like iron 3 plus aqueous plus 3 nitrates aqueous plus 3 potassiums aqueous plus 3 hydroxides aqueous yields iron 3 hydroxide solid. We don't ionize that because it's a solid. And then we're going to have 3 potassiums that are still aqueous and 3 nitrates that are also aqueous. So that would be our full ionic equation. I just wrote that out so we can kind of maybe make it a little bit easier to see what our spectator ions were. So what are our spectator ions? What should we cancel out from that reaction? What goes through the reaction unchanged? It's the same on both sides. Yeah. Yeah, right. The nitrate is the same on both sides. Nitrate, nitrate gone. Potassium, potassium gone. And so that gives us our net ionic equation. Our net ionic equation is iron 3 plus aqueous plus 3 hydroxide aqueous yield iron 3 hydroxide solid. I remember distinctly on this exam, a lot of people got these questions wrong because they didn't read the full question. If the question asked for net ionic equation, quite often people did not answer. They answered in a correct equation, but they did not answer in the net ionic equation. You included the spectator ions or things like that. There was a question where it was, what are the spectator ions in this question, in the reaction? And same problem. Many of you actually answered what precipitated from the reaction, not what was the spectator ion, what stayed in the reaction or went through the reaction unchanged. So just be very careful when you're reading those questions on the final exam. What is the question asking? Is it asking for my molecular equation, the net ionic? Is it asking for what are my spectator ions in that reaction? Any questions on that? Yeah, we knew to make it this way because iron 3 hydroxide, that Roman numeral 3 means iron has a 3+ charge on it. And we look down at this chart here, right? Handy thing of having this chart on the exam. We should know the polyatomics, but if you didn't, okay, I've got iron 3 nitrate. Well, that means iron is 3+ and nitrate is -1. So that means I need to have 3 of those nitrates to balance out the charge on iron. Potassium hydroxide, potassium is group 1, that should be +1. Hydroxide is -1. So those two balance out. Then when we made the product, okay, hydroxide is still -1, and that's also on the chart here, right? Hydroxide is -1. Well, iron is still 3+, so if hydroxide's -1, I need to have 3 hydroxides balance out the charge that's on iron. And then by default, to kind of balance our question out, right? Well, I've got 3 nitrates over here. I need to have 3 nitrates over here. If I need 3 hydroxides, I needed 3 potassium hydroxide, so I need that coefficient of 3 there as well. So that's why we kind of went back through and came up with those coefficients to help us account for everything else. But yeah, those charges, iron 3 nitrate is going to come together to form a neutral compound, right? It wants to form a neutral compound. So if iron's 3+, I need a -3 charge to complement that. Yeah, any other questions on this one? All right.